The purpose of this lesson is to demonstrate how to find the volume of pyramids and cones. The definitions are down below. They are 1/3 capital B H, where the capital B is the area of the base, and the height is the height of the solid. The major difference between a volume formula and a surface area formula is in surface area we were using that L for slant height. However, if you notice here in this formula, we are actually using the height. And again, the reason is if we think about volume and we think about all of these squares that are added up, there are squares upon squares upon squares upon squares. So we're talking about the bottom of the shape all the way to the top. I found a short website, or a quick website, that I just wanted to show you. And it talks about why the volume of a pyramid is 1/3 capital BH. It says, first we must take a look at the properties of triangular prisms. Look at this spot right here. It says the prism can be cut into 3 different pyramids that do not overlap. It can also be shown that these pyramids have the same volume. So right down here, they're trying to show you the 3 different ones. So in this first diagram, they've drawn a pyramid kind of through the center, and now they're drawing the second one. And in the third diagram, they're showing you the third pyramid that would kind of be formed where this EDC would be. So there are 3 pyramids within one prism, which is why the formula is 1/3. That's the same formula for a prism. Cones are circular versions of pyramids, so the same idea that they're 1/3 capital BH. Capital B there is area of the base. Good thing about cones is that the base is always going to be circular, so we're going to tweak this formula 1/3 pi r squared h. Just note that the volume for oblique solids, the ones that are kind of pushed over, is the same for solids that are straight up and down, referred to as right solids. 3 problems. It says find the volume. I'm going to have to assume, even though it doesn't 100% look like it, that this is a square pyramid. If they wanted it to be a shape other than square, they would have had to have given me that length. Let's see, the volume is 1/3 capital B H. H here is unknown, but they did give me slant height. I can figure out this, it's half of this base, so I end up using Pythagorean theorem. There's a 20, I need to find the height, but they gave me slant height. 20 squared plus h squared equals 25 squared. When I did that, I got an h value of, let's see, I'm showing 15. Let me calculate it one more time. 25 squared minus 20 squared. Yep, h is going to be 15. So I'm going to do 1/3. The area of that bottom is 40 times 40, 40 squared, and the height is 15. Grab your calculator and type it out. I ended up with volume being 8,000 feet to the 3rd power. All right, this one is referred to as an oblique cone because it's been pushed over, but the formula is still the same, 1/3 pi r squared h. So 1/3 pi, the r is going to be 2, so 2 squared is 4, times the height. So 4 times 4 is 16. 16 divided by 3, heck, I'm just going to leave it as 16/3 pi. This is exact terms. If you want to type it in, I guess we could. 16 divided by 3 times pi. Ended up giving me the decimal 16.8 if we round to the, cube, to the nearest tenth. All right, this last one is a composite. Composites are much easier for volume because you're not having to worry about any extra bases or taking things out that are hollow or anything like that. We have here a cone, and we have to take out of it half of a sphere. And the sphere is kind of shown in here with this dotted, kind of dotted line thing. So your half a sphere is in here. What I think is harder about this particular problem is just deciphering what goes where. So if you look closely, it's showing you that the 8 is the radius in the sphere, and it's showing you that the 10 goes from the center of both all the way out to the edge of the cone. So here the R is going to be 10. So I'm going to do, let's see, 1/3 pi r squared h, which is going to be 1/3 pi times 100 times 24. So I'm just going to keep finishing that calculation. I believe it's going to be 800 pi. I did 1/3 of 24, so 24 divided by 3 was 8 times 100. Okay, now I'm going to do half of a sphere. So I'm going to leave the half for a second. Sphere is 4/3 pi r to the third. So this is going to be 1/2 4/3 pi r. R is 8 to the third. All right, 8 to the third power is 512, and I'm going to multiply it by 4/3. Oh, this is going to be nasty. I think I'm going to have to get rid of my pies. All right, what if we do this? Grab your calculator and just get all that out, because it's going to give you kind of a crappy decimal anyway. So I'm going to do 800 pi minus 0.5 times 4/3 minus 4/3 times pi times 8 to the third. And I ended up with a pretty big number, which kind of makes sense because the height of this thing was 24. I got 1,440, rounded to the nearest tenth was 0.9 millimeters to the third. All right, looks like we have one more. Find the value of x. So this is a triangular pyramid, which means when we find capital V, 1/3 capital B times h, that capital B is of the triangle. So we're being given volume, 1/3, let's see, oops, 1/3. I'm going to write, let's see, if we want to find the area of that capital B, it's actually helpful that they gave you the 90 degrees, because you can think about it as base and height. 1/2 9 times x. So I'm going to put that down over here. And then we still have to multiply it by height, which they gave us as 14. All right, let's do a little bit of simplifying. 1/3 times 1/2 is 1/6. I'm going to do 9 times 14 is 126x. Let's see if that divides out nicely. Ooh, it does. So 126 equals, I just multiplied, that's all I'm doing. Your calculator can take care of it too if you need to trust it. And then I'm going to divide both sides by 21. And it ended up with 6. And we don't have any sort of a unit. So this isn't going to be squared because we're dealing with a particular length. If you wanted to check it, you could. Volume equals 1/3, let's see, 1/2, 9 times 6 times 14. 3 times 9 times 14. Yep, it ends up working out perfect. We did it all right. All right, so that's it. It's a short lesson. Volume is hopefully easier than the others. If you have any questions, please let me know.